Hello class, we're in chapter 6.5 learning about the power of water, ice, and steam. So today we're going to learn about the three states of matter. The first of what is matter? We did learn in the beginning of chapter number 6 that matter is anything that takes up space, has mass, and weight. So matter is anything that takes up space and has mass and weight. But there are three basic forms of matter. We have solid state of matter, the liquid state of matter, and then we have the gas state of matter. Now, what is the solid state of matter? The solid state of matter will be, for example, a phone. A phone is solid because it has what? A definite shape. A desk will be solid because it has a definite shape. Liquid. Liquid will be like water. Water has no permanent shape because the shape of water is going to be different depending of what we have. If we have a bowl, water will fill up, making the shape of a bowl. If we have a water bottle, water will fill up, making the shape of the water bottle. That means liquid itself has no permanent shape. And then we move on to a last state of matter, which is gas. And as well, it has no permanent shape. Gas will be like air. Does air have a shape? No. So gas has no permanent shape. But there is one thing that can be all solid, liquid, and gas. You're going to be like, what? There is one thing that can be all three forms of matter? Yes, and it's actually water. Water can be either solid, it could be liquid, or gas. It's going to be solid when it is ice, it's going to be liquid when it is water, and it's going to be gas when it changes to steam. So moving on, as we learn about the states of matter, we do have to know that liquid and gas are called fluids because they can flow from one place to another. Very easy to memorize, fluids and flow. So fluids because they can flow from one place to another. Again, a solid material such as a desk cannot flow from one place to another. But a liquid such as water or steam can flow from one place to another. Now let's go to learn about diffusion. We do have to know about diffusion for today's classwork. So diffusion is a tendency of gases to float away and spread themselves out thinly in their surroundings. So it would be like water and salt. Whenever we have a glass of water and we add salt to it, do we already have salt water? I'll say no. Because all the salt is going to be what? Down in the bottom. Now, how do we mix up the water and the salt? We have to mix it. We have to stir it. Whenever we stir it, the salt is going to be everywhere around that glass of water. That is diffusion. As you can see, it's a tendency of gases to float away and spread themselves. The salt spread it to the glass of water. It's not in one single spot, but it's spread it around its surrounding. So we're going to learn about diffusion. It's something we have to know for today's classwork. Now, let's go and learn about the changes in state. Like I told you, water could be either solid, liquid, or gas. Now, when it is solid, when is water liquid, and when is water gas? First up, we have the melting point. Melting point is a temperature at which a substance changes from solid into a liquid. Melting point, it melts. So from ice to water, the temperature changes. The temperature at which a substance changes from a solid into a liquid. Again, ice to water. And then we have the freezing point, the temperature at which a substance changes from a liquid into a solid. Now, vice versa, we have water changing into ice. By what? We go and place the water to a freezer and it changes into ice. So we have the melting point of water and then we have the freezing point of water. We did learn this in math as we were learning about temperature. That means with temperature, one thing can change from one state to another state of matter. Temperature of both melting and freezing point is 32 degrees Fahrenheit. You have to know this by memory. Temperature of both melting and freezing point is 32 degrees Fahrenheit. Now moving on. So we did learn the melting point when solid changes into liquid and when liquid changes into solid. Now when liquid changes into gas, we have the boiling point. The boiling point is a temperature at which a substance changes from a liquid into a gas. So whenever you boil some water, you know how you have some steam? It's because that water just changed into gas. The temperature at which a substance changes from a liquid into a gas. And then we have the condensation point, the temperature at which a substance changes from a gas into a liquid. So we did learn about condensation when we were learning about the water cycle. So whenever water evaporates, it changes into gas and then it will condense. That gas will become liquid again. So that's the condensation point, when the temperature at which a substance changes from a gas into a liquid. Now, know this temperature by memory. Water boils and condenses at 212 degrees Fahrenheit. So both water boil and condensation, the temperature will be 212 degrees Fahrenheit. So we have the freezing point and the melting point, which is going to be 32 degrees Fahrenheit. And then we have the boiling point of water and the condensation point, which is going to be 212 degrees Fahrenheit. So water in 3 states. Remember in the beginning of the first slide, I said there is one thing that can be all 3 states of matter. It could be solid, it could be gas, and it could also be liquid. And that is water. So water, 3 states. We have ice, which is a solid water. Then we have water, which is a liquid water, the water that we drink. And then we have steam, which is water as gas. As you can see, ice is solid, water is liquid, steam is gas. Do we have all 3 states of matter? Yes, but in that certain state of matter, in ice, in water, and in steam, we have molecules inside that certain water. But the molecules, though, will be moving differently when they are solid, when they are liquid, and when they are gas. Now let's go to learn about the different motions of the molecules in the 3 different states of matter. So water is made of tiny particles called molecules. So we did learn about H2O, remember? And which is the scientific name of water. And we know that water is made out of tiny particles called molecules. The amount of kinetic energy. So what is kinetic energy? Kinetic energy is movement. So the amount of movement that water molecules have will determine whether the water is solid, liquid, or gas. That means if the kinetic energy is very high, that means the molecules are running back and forth and floating back and forth. That will probably tell us a state of matter. But if the molecules are in one place, the kinetic energy is very, very slow. That means it is telling us that this certain water is another state of matter. So depending on the kinetic energy that water molecules have will determine the state of matter. So let's go and learn about the motion of molecules whenever it is ice, whenever it is solid. So when we have water in a state of solid, which is ice, molecules will arrange themselves in layers of interlocking hexagons. That means crystals. That means all the molecules are like together. They're completely together, but they are constantly vibrating. Now, whenever it's cold, we get together and we want to conserve heat. It will be like that, but with molecules. They are all together. They don't want to be separated, but they are constantly moving. They are vibrating. So the molecules are constantly what? Vibrating. They're moving, but not a lot. Now moving on to water. Water becomes more dense. That means heavier and compacted. Molecules will fill the empty spaces in the crystals. This time though, the molecules of water, whenever it is liquid, it is moving. So one thing, it will be ice. I am running in place. So let's say I am a molecule and I'm explaining the motions of the molecules. When I'm a molecule in ice, I am running in place. Am I moving? Yes, I am, but I'm running in place. Water, though, I am walking around the class. So I'm walking around the class. As you can see, do I have more kinetic energy? Yes, I do. So that'll be water. And the last one will be steam. Molecules fly, move so fast that they are not held together. So this time in my class, I will be running around my class because I am moving so fast. As you can see, we can see the three differences in the motion of the molecule. If I am a molecule and I am a molecule in ice, I'll be running in the same spot, running in the same spot. If I'm water, I'm walking around the class. When I'm gas, which is steam, I'll be running around the class. As you can see, the difference in the kinetic energy. So so what's gonna be today's lesson, today's classwork though? We're gonna use this concept of states of matter and the motions of molecules. What we're gonna do, we're gonna have two different cups. You're gonna read this in page 165, which is watching molecules move. You're gonna have two clear plastic cups, and then you're gonna have some food coloring. You don't need food coloring. If you don't have food coloring, you can do it with juice. You can do it with liquid paint. And what you're going to do, you're going to add 1 drop of that to the water. But here's the difference. 1 cup of water is going to be cold water, and the other cup of water is going to be hot water. The paint or the food coloring is going to diffuse in a different speed because the molecules are moving differently. Because in cold water, the molecules are what? Moving slowly. But in hot water, which is almost steam, what's going to happen? Molecules are moving very fast. What you're going to do today, you're going to try that at home, and you're going to tell me through Class Dojo what happened. You're going to answer this following questions. Does the coloring diffuse faster in the cold or in the hot water? And the second question is going to be, why does it diffuse quickly in one and slowly in the other? So that's going to be your classwork today. We did learn about the 3 states of matter. Goodbye.